2020 National Electrical Code allows splices in panel boxes and load centers under certain conditions. Firstly, there must be sufficient space within the panel to make and maintain splices without overcrowding or obstructing accessibility to other components. Secondly, the panel or load center must be listed, for example by UL, for the type of wiring method being used, such as splices. However, manufacturers may specify additional requirements that supersede the NEC. For example, if a load center is not listed as a gutterway, splices may not be permitted. Restrictions on splices in panel boxes and load centers exist for safety reasons. Splices can introduce points of failure or potential arcing. Splices may make it more difficult to isolate circuits for maintenance or troubleshooting. Splices can reduce the amount of space available for other components, such as circuit breakers. To ensure safety and compliance with code and manufacturer requirements, it is generally advisable to avoid splicing within panel boxes and load centers if possible. Instead, consider using wire nuts or terminal blocks in junction boxes or other suitable enclosures. While the NEC allows splices in panel boxes and load centers under certain conditions, it is important to prioritize safety and consult both the code and manufacturer specifications to determine the specific requirements for a given installation. In more detail, the National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It aims to ensure the safety of people and property by providing regulations for electrical wiring, overcurrent protection, grounding, and other electrical system components. The NEC is updated every 3 years to incorporate new technologies and address emerging safety concerns. It is widely adopted by state and local jurisdictions in the United States and serves as a basis for electrical codes in many other countries. Understanding the NEC is essential for electricians, electrical engineers, inspectors, and anyone involved in electrical work to ensure compliance and prevent electrical hazards. The concept of listing in the context of electrical equipment refers to the process by which a recognized testing laboratory, such as Underwriters Laboratories, or UL, evaluates and certifies that a product meets specific safety standards. When a product is listed, it means that it has been tested and found to comply with the applicable requirements for its intended use. This listing is often indicated by a mark or label on the product, providing assurance to consumers and installers that the equipment has been independently verified for safety. Electrical inspectors and authorities having jurisdiction, or ODGs, often require that electrical equipment be listed to ensure compliance with safety codes and regulations. Using listed equipment helps to reduce the risk of electrical hazards and promotes safer electrical installations. A gutterway in electrical systems refers to a metallic or non-metallic trough or channel used to enclose and protect electrical conductors. Gutterways are typically installed in commercial and industrial settings to provide a pathway for multiple wires or cables. They are often used to route conductors from one location to another, such as from a panel board to a distribution point. Gutterways can be open or enclosed, and they come in various sizes and configurations to accommodate different wiring needs. They provide a convenient and organized way to manage and protect electrical conductors, reducing the risk of damage and ensuring compliance with electrical codes. The NEC specifies requirements for the installation and use of gutterways, including grounding, support, and conductor fill limitations. Wire nuts are a type of electrical connector used to join two or more wires together. They consist of a plastic or ceramic cap with a tapered, threaded metal inset. To use a wire nut, the ends of the wires to be joined are stripped of insulation, twisted together, and then the wire nut is screwed onto the twisted wires. The threads inside the wire nut grip the wires, creating a secure and insulated connection. Wire nuts are commonly used in residential and commercial electrical wiring for making splices and terminations in junction boxes, outlets, and other electrical enclosures. They are available in various sizes to accommodate different wire gauges and numbers of conductors. Wire nuts are a convenient and cost-effective way to make reliable electrical connections, but it is important to select the correct size and ensure that the wires are properly twisted and secured to prevent loose connections and potential electrical hazards. Terminal blocks are modular electrical connectors used to terminate and connect wires in a variety of electrical and electronic applications. They consist of an insulated housing with metal terminals that allow wires to be securely clamped or screwed into place. Terminal blocks provide a convenient and organized way to connect multiple wires together, making it easier to install, maintain, and troubleshoot electrical systems. They are available in various types, including screw terminal blocks, spring clamp terminal blocks, and insulation displacement connector or IDE terminal blocks, each offering different connection methods and advantages. Terminal blocks are commonly used in control panels, distribution boards, and other electrical enclosures to provide reliable and easily accessible connection points for wires. They help to reduce wiring errors, improve circuit organization, and facilitate future modifications or expansions of electrical systems. A junction box is an enclosure used to house electrical connections, splices, or terminations. It provides a safe and protected space for joining wires together, preventing exposure to environmental elements and reducing the risk of electrical hazards. Junction boxes are typically made of metal or plastic and come in various sizes and shapes to accommodate different wiring needs. They are commonly used in residential, commercial, and industrial electrical installations to connect lighting fixtures, receptacles, switches, and other electrical devices. Junction boxes must be installed in accordance with electrical codes and regulations, including requirements for grounding, securing, and access. They are an essential component of electrical wiring systems, providing a safe and organized way to make electrical connections and ensure the integrity of electrical circuits. Overcrowding in electrical panels refers to a condition where there is insufficient space within the panel to safely accommodate all the wiring, components, and connections. Overcrowding can occur when too many circuits are added to a panel without upgrading its capacity, or when wires are not properly organized and routed. This can lead to several problems, including difficulty in accessing and maintaining components, increased risk of electrical shorts and fires, and reduced ventilation, which can cause overheating. Electrical codes and standards, such as the NEC, specify minimum clearances and spacing requirements for electrical panels to prevent overcrowding and ensure safe operation. It is important to avoid overcrowding in electrical panels by properly planning and sizing the panel for the intended load, using appropriate wiring methods, and maintaining neat and organized wiring practices. If overcrowding is present, it may be necessary to upgrade the panel or redistribute the circuits to alleviate the problem. Accessibility in the context of electrical panels refers to the ease with which electricians and other qualified personnel can access and work on the components and wiring within the panel. Electrical codes and standards, such as the NEC, specify minimum clearances and working spaces around electrical equipment to ensure safe and convenient access for maintenance, troubleshooting, and repairs. Accessibility is important for several reasons, including facilitating routine inspections and testing, allowing for quick and easy identification and resolution of electrical problems, and reducing the risk of electrical shock or injury during maintenance activities. Obstructions, such as boxes, equipment, or stored items, should be kept clear of electrical panels to maintain accessibility. Adequate lighting and clear labeling of circuits and components also contribute to improved accessibility. By ensuring proper accessibility to electrical panels, electricians can work more efficiently and safely, minimizing downtime and reducing the potential for electrical hazards. An arc fault is an unintentional electrical discharge that occurs when current flows through an unintended path, such as a damaged wire, loose connection, or faulty insulation. Arc faults can generate intense heat and sparks, which can ignite nearby combustible materials and cause fires. They are a leading cause of electrical fires in homes and businesses. Arc fault circuit interrupters, or FSIs, are devices designed to detect arc faults and quickly shut off the power to the affected circuit, preventing a fire from starting. FSIs are required by electrical codes in many locations for certain circuits, such as those serving bedrooms and living areas. They provide an important layer of protection against electrical fires, complementing traditional circuit breakers, which primarily protect against overloads and short circuits. Regularly testing of size is recommended to ensure they are functioning properly and providing the intended level of protection. Wire gauge refers to the standard measurement used to specify the diameter or thickness of electrical wires. The American wire gauge, or OG, system is commonly used in the United States to classify wire sizes. In the AWG system, smaller numbers indicate larger diameter wires, while larger numbers indicate smaller diameter wires. For example, a 12 AWG wire is thicker than a 14 AWG wire. Wire gauge is important because it determines the amount of current that a wire can safely carry. Using a wire that is too small for the intended current load can cause the wire to overheat, leading to insulation damage, electrical fires, and other hazards. Electrical codes and standards specify the minimum wire gauge required for different types of circuits and applications based on the expected current load and other factors. It is important to select the appropriate wire gauge for each electrical circuit to ensure safety and prevent electrical problems. In electrical terms, a circuit breaker is a protective device designed to automatically interrupt the flow of electricity in a circuit when an overload or a short circuit occurs. Circuit breakers are an essential component of electrical systems, preventing damage to equipment and reducing the risk of electrical fires. They work by sensing excessive current flow and tripping a switch that breaks the circuit, stopping the flow of electricity. Circuit breakers can be reset manually after the fault has been cleared, allowing the circuit to be put back into operation. They are available in various sizes and types to protect different types of circuits and equipment. Circuit breakers are rated in amps, which indicates the maximum current they can safely carry before tripping. It is important to select the appropriate size circuit breaker for each circuit to ensure proper protection. Regular inspection and testing of circuit breakers are recommended to ensure they are functioning properly. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It represents the force that drives electric current through a conductor. Voltage is analogous to pressure in a water pipe, with higher voltage corresponding to greater pressure and greater potential for current flow. In electrical systems, voltage is typically supplied by a power source, such as a battery, generator, or utility grid. Common voltage levels in residential and commercial buildings include 120 volts and 240 volts. Voltage is a critical parameter in electrical circuits affecting the performance and safety of electrical equipment. It is important to ensure that electrical equipment is operated at the correct voltage to prevent damage and ensure proper functioning. Electrical codes and standards specify voltage requirements for different types of circuits and applications. Amperage, often referred to as current, is the measure of the rate of flow of electric charge in a circuit measured in amperes or amps. It represents the quantity of electrons passing a given point in a circuit per unit of time. Amperage is analogous to the flow rate of water in a pipe, with higher amperage corresponding to a greater flow rate. In electrical systems, amperage is determined by the voltage and resistance of the circuit according to Ohm's law. Electrical equipment and circuits are rated for a maximum amperage, which indicates the amount of current they can safely carry without overheating or causing damage. It is important to ensure that the amperage of a circuit does not exceed the rating of the circuit components, such as wires, circuit breakers, and equipment. Exceeding the amperage rating can lead to overheating, insulation damage, and electrical fires. Electrical codes and standards specify amperage requirements for different types of circuits and applications. Resistance is the opposition to the flow of electric current in a circuit measured in ohms. It represents the degree to which a material or component impedes the flow of electrons. Resistance is analogous to friction in a water pipe, with higher resistance corresponding to greater friction and reduced flow rate. In electrical systems, resistance is determined by the material, length, and cross-sectional area of the conductor, as well as temperature. Electrical components, such as resistors, are designed to provide a specific amount of resistance in a circuit to control the flow of current. Resistance is a critical parameter in electrical circuits affecting the voltage, current, and power dissipation. It is important to consider the resistance of circuit components when designing and analyzing electrical circuits. Electrical codes and standards may specify resistance requirements for certain types of circuits and applications, such as grounding systems. NEC Table 310.15b16 is a crucial reference for electrical professionals, providing ampacity ratings for various types of conductors based on their insulation type, size, and insulation conditions. Ampacity refers to the maximum amount of current, in amperes, that a conductor can carry continuously under specific conditions without exceeding its temperature rating. The table takes into account factors such as ambient temperature, the number of current-carrying conductors in a raceway or cable, and the type of insulation used in the conductors. By consulting NEC Table 310.15b16, electricians and engineers can ensure that they are using conductors of the appropriate size and type for the intended application, preventing overheating, insulation damage, and electrical fires. The table is essential for compliance with electrical codes and standards and is regularly updated to reflect new technologies and materials. Electrical enclosures are protective housings designed to enclose electrical components and wiring, providing protection against environmental elements, physical damage, and electrical hazards. They are commonly used in residential, commercial, and industrial electrical installations to house circuit breakers, transformers, control panels, and other electrical equipment. Electrical enclosures are typically made of metal or plastic and come in various sizes and shapes to accommodate different types of equipment and wiring configurations. They are designed to meet specific requirements for protection against water, dust, corrosion, and other environmental factors. Electrical enclosures must be installed in accordance with electrical codes and standards, including requirements for grounding, sealing, and access. They are an essential component of electrical systems, ensuring the safety and reliability of electrical equipment and wiring. Underground wiring refers to electrical conductors that are installed below the surface of the ground. Underground wiring is commonly used in residential, commercial, and industrial electrical installations for a variety of reasons, including aesthetics, safety, and protection from weather and physical damage. Underground wiring can be installed in conduit, direct buried cables, or underground duct banks. It is important to follow specific requirements for underground wiring installations, including burial depth, conductor type, and protection from physical damage. Electrical codes and standards, such as the NEC, provide detailed guidelines for underground wiring installations to ensure safety and prevent electrical hazards. Proper installation of underground wiring is essential for reliable and long-lasting electrical service.